morning, everyone. I am Chaitanya Shukla, and me and my group, mentored by Dr. Sunil Karamchandani, will be presenting on the optimizing banks' financial risk by forecasting future NPA uh, using machine learning. So first we need to understand what is NPA. So NPA is a classification which is used by financial institution for loans and advances on which the principal is past due and on which no interest payment have been made for a period of time. So in general, loans become NPA when they are outstanding for 90 days or more. So so let us take an example of Bharat Pay. Uh, for example, I am a small scale shopkeeper and I want to take a loan of 2 lakh rupees. So I will approach Bharat Pay. But how Bharat Pay will give me the loan? So Bharat Pay has developed an artificial intelligence based algorithm that picks up various signals, the kind of transaction a user does, their usage of the products on the platform, and etc., which gives them an insight into my business's cash flow. So this is then analyzed in tandem with the user's loan history and credit score to make a loan offer. So after doing all this, I will be offered a loan. So let us look at our proposed system. So like Bharat Pay has developed a system, even we have developed a machine learning system which has 8 fundamental steps. So step one is financial data pre-processing and authentication. So when it comes to financial data, the data has to be authenticated. Our data is authenticated by Stanford University and is of a lending club, which is a very famous in USA. The next step is exploratory data visualization. The data set is very massive and it is very time consuming to understand each and every aspect and integrity, and hence we have visualized each column with other column, which makes us easier to decision making process. Next step is feature engineering, which is core of our machine learning algorithm. Why? The data set has more than 70 features, and for a user to fill 70 features, it is monotonous and lethargic process. So we have only 10 columns, and user can fill it and will get to know the loan amount will be charged off or not. So next step is standardize statistic for evaluation. So as to give complete evaluation of our ML algorithms, we have standardized 5 statistic for evaluation, and they are as follows: precision, recall, accuracy, kappa coefficient, and Gini coefficient. The first 3 are given by the classification report, and the other 2 are found by random accuracy and decision tree classifier. So the fifth step is implementation of ML algorithm. So our main motive was to apply different ML algorithms, starting from logistic regression and ending at LGBM classifier, that stands from light gradient boosting classifier. In between, we have applied decision tree, random forest, KNN classifier, naive Bayes classifier. So after applying all these 6 algorithm, the next step comes into picture, uh, which is after applying all the 6 algorithms and standardizing stats for evaluation, we got to know that the random forest is the best classifier among all the algorithm, and thus we have developed the entire model and deployed the entire model on Streamlit. The penultimate step is a Microsoft Azure API. Here we create a web service input and web service output for end-to-end API access. Uh, uh, End-to-end API access. So, but what is API? For example, a person wants to change our project, but wants to change our project by remotely. How we will do it? He will do it with the help of API. So the next step comes into picture, which is the final step, where we will create an end-to-end user website where user will get to know about all the features, their importance and data visualization which we have done, and we will create Google form integrated on our website, so as to whenever person wants to access API, he will just have to fill the form and API will be mailed to that particular person. So now we will be showing the graphical representation of our proposed system. So as you can see, this is the graphical visualization of our proposed system. The important data visualization will be explained by Aditya Kamath.
Hello, I'm Aditya Kamath, and I will be explaining the various graphs used in the project. Uh, this is the first visualization, and it is the loan status distribution. As you can see, uh, the fully paid consists of 80.5%, and the charged off consists of 19.5%. So our main aim is to perform NPA. The data is highly imbalanced, so we need to balance it by using various ML techniques. So the next visualization. This visualization shows a graph of the loan amount distribution. This shows amount of loan distributed over a course of period or time. As you can see, the small amounts of loan have higher data rates as compared to the larger amounts. This is because banks and NBFCs have high rate of interest or smaller amounts, around 8 to 10%. Example, a car loan or a personal loan. This is what we can see in this distribution. Now the next graph. This graph shows employment length and the amount of loan distributed. As I said in the previous graph, when amount increases, rate of interest decreases. This can be shown by education and housing loan. And whenever it is more than 10 years, amount increases up the rate of interest like 6% and max to max 7%. And inflation is around 6%. Technically, we are seeing interest of 1 year. When a person buys loan of a higher amount, NPA is around 10 to 15 years, and then he will be able to take home loan or education loan for his family. The next graph. The next visualization is the issuance of loans. This is between average loan amount is issued and years. Whenever bank gives loan, they have to give entire amount to the RBI for risk analysis, and this shows increase in issuance of loans, and in some cases we can see a significant decrease as well. Next. The next graph, this shows this graph is between home ownership and loan distribution count. Whenever user goes to a bank or NBFC, highest they can get is around 60 lakhs. And as you can see in this graph, the mortgage is very high, and loan which is charged off by own is also shown here. Now the last visualization. Coming back to our data set, we had around 50 columns, and after feature extraction, we came around 10 to 15 columns, which includes loan amount, installment, annual income, FICO range, and other terms. This visualization shows a heat map, which we have plotted, which shows correlation between each variable with all the various other variables, starting from 0.15 to max amount of 1. Now the ML interpretation will be explained by Drumil Joshi.
So hello everyone, my name is Drumil Joshi and I will be explaining the ML interpretation. But before starting this interpretation part, I want to make sure that before coming to this project, we wanted to give a brief classification about all the algorithms performing in our data set. So we have chosen 6 algorithms of various different types, and thus we have evaluated them on 6 different metrics as shown in the graph. To first start with, the first one is the logistic regression. That is a baseline model to go for a brief comparison, and it works on the sigmoid probability. So thus we can get a precision of 0.95, but a kappa coefficient of 0.707. And though the model is a bit, what can we say, it's a bit overfitting, but it's not considered to be great considering the sigmoid probability, which gives the result of 0 and 1. The next we have implemented is the decision tree classifier. Decision tree classifier is based on the tree structure and gives the output whether a yes or a no. So this classifier is highly affected by the bias variance trade-off, and thus the multicollinearity plays an important role, and thus this classifier is rejected at the initial stage itself. The third classifier which we have implemented is the Gaussian NP classifier. As we all know that the Gaussian NP classifier is works on a it works on a principle of normalization, that is it tries to bring the data into a bell-shaped curve so that the evaluation becomes a bit easy for the accuracy metrics as well. So here we can see like we get a kappa coefficient of 0.52 but a precision of 0.98. Though in our case we want a recall factor to be very much higher as compared to the precision, because the data should be recalled as compared to the previous data for the prediction of NPA. So here the Gaussian NP is rejected as well due to a very low recall factor as compared to the others. The fourth classifier we have implemented is the random forest classifier. Random forest classifier is also known as the ensembling classifier. So the drawback of the decision tree classifier was that they form just only one tree structure and they give output whether a yes or a no. And random forest classifier just accumulates all the decision trees for all different scenarios, and thus it gives an accuracy of 0.97 and the recall factor of 0.98, which is a very significant amount. And thus we can even say that the random forest classifier is immune from the bias variance trade-off, considering all the features and like all the feature engineering techniques. And even if we have implemented the best features which affect the result and would be shown in further slides. And when we come to random forest classifier, we have a kappa coefficient of zero point 0.5 as well as a Gini coefficient of zero point 0.5, which shows the region of interest is very much into our domain, and thus we can go and is considered to be the one of the best classifiers out of the six. The next classifier which we implemented is the KNN classifier. As the name suggests, KNN classifier is known for is the like the nearest neighbor things, but we can clearly depict that the Gini coefficient is 0.32. So that clearly states that the model has to be neglected as it just goes for the neighbors which are related to each other, thus leading to a very short Euclidean distance. And thus though it has a high recall factor, we can definitely say that the model is not performing in certain scenarios. The last classifier which we have implemented is the LGBM classifier. Our main motive was to apply a boosting classifier, but when we boost the model parameters of any algorithm, we would get an accuracy of 0.99 and even a 1. But we need the Gini coefficient to be like in the domain of 0.7 to 0.85. So thus we went for a LGBM, that is light gradient boosting classifier. Though it gets an accuracy of 0.98 and an F1 score of 0.99, we can clearly depict that the model is overfitting and it will give yes answer to each and every scenario, whether it is an outlier or not. So thus this model is also neglected considering the overfitting thing. And like we have this important features which will be explained by Aditya.
Hello, so I'm Aditya Iyengar, and I will be explaining the parts about the deployment and the end-to-end website development. So as you can see here in this slide, these are the most important features that we had analyzed, that we obtained after analyzing the graphs. The first is last payment amount, the amount that the last payment done by the customer for the bank. The total loan. Second is total loan amount. This is the total loan amount taken by the customer. Second is the interest rate that is given on his loan. The third is the debt to income ratio. The fourth feature is the revolving line utilization rate. It is the amount of credit the borrower is using relative to all available revolving credit. The next is the total credit revolving balance. The next is annual income. This is the annual income that the person that the customer gets for as a salary. Then next is the FICO range. The ninth is the earliest credit year, and the 10th is the total number of accounts that are open in his bank. Next. So here we will see about the Streamlit deployment. Here Streamlit is a framework which is open source and is used extensively for making web apps for machine learning algorithms. To deploy a machine learning algorithm via Streamlit, first the model itself is encoded in a pickle format. This is done by an encoding procedure that is integrated into Python itself. Then this encoded algorithm must be decrypted in a Python script file, and then its various input parameters have to be entered. So after describing its parameters, which are the most important features shown in the previous slide, a function will be created wherein it will take the user inputs and then the function runs the trained model and displays the result. So there are various extra files which are setup.sh and requirements.txt, which are mandatory for the creation of app, that since they specify the software and the respective versions that have to be used. Every field function inputs, heading, and the web app itself can be heavily customized by HTML, since Streamlit is extremely flexible in supporting the HTML and CSS plugins. This fully prepared model and its various other files are then uploaded to GitHub, and the repository link, after setting up all the index pages and the links and all, is provided to Streamlit, wherein this Streamlit software will then examine all files and combine them to create a web hosted application which will be publicly available to everyone on the internet for free usage. Next. Now the main website. This is the end-to-end user part. We shall make use of HTML, CSS, and Bootstrap for designing the fully interactive front-end website, which will house all content related to this project. So the software used and the descriptions are: HTML is known as hypertext markup language. This is a standard markup language. It is used for programming and creating of websites, like the building block of any website. Next is CSS. CSS is cascading style sheet. CSS is basically a language which allows extensive aesthetic customization of our websites. It can either be a separate file linked to a website, or the entire code of the CSS can be housed inside the HTML code using the style tag. Bootstrap. Bootstrap is a free and open source web development framework which has an extensive combination of CSS and JavaScript, and it is used to provide websites with interactive buttons, menu bars, mini slideshows, and much more. This framework behaves almost like a separate programming language itself. The next is Font Awesome. Font Awesome is basically a very large and extensive collection of icons which can be easily imported and used in perfect combination with Bootstrap for enhancing the interactivity and aesthetic look of a website. Next. Here we have 7 total web pages of our website, which basically are the home page. This consists of our project goals and summary and are basically a synopsis of it. The systems, thanks to the systems page, this describes the existing system that is currently in use and the proposed systems which we will use using the machine learning. Next is the important graphical analysis page. This page contains all the background exploratory data analysis performed, all the graphs that were obtained, and all the evaluations. The next is the ML machine learning metrics page. This displays and compares the machine learning models that are taken in consideration using the evaluation metrics. Next is the implementation of Microsoft Azure page. This describes the API generation process via the Microsoft Azure, which the API will then distribute it to the users via the Google form. And then demonstration page describes the various model parameters and contains a button styled button which can open the web app for easy access, and it will be free on the internet for anyone to use. Then next is the access to the API key page. This page contains an embedded Google form providing API access to all the users who fill it. Next. So these are all the screenshots that we have taken after fully deploying our website. Next. This is the systems page. Next. This is the important data visualization which contain the EDA graphs page. This is the machine learning implementation, wherein all the graphs and the comparison metrics that we used for analyzing and obtaining the perfect machine learning algorithms are given. Next. This is the demonstration page. This page we have described all the model. This is the Microsoft Azure page. Here we have described the API generation process. Next. This is the ML prediction page. Here we have described all the various input parameters, and we have also added a button to open the final app. Next. This is the access to API key page. This contains a Google form as shown here. Thank you.